Okay, so hi guys, I'm Bhattacharya and today we'll be learning about acid-base theories. Now, when we mention about acid-base theories, the most common reference to this specific class of compounds known as acid and base comes from mainly after having a meal. What do I mean? Well, you guys must have heard about complaints mainly from older people about having an acidity. Now, what is that acidity and how is it that acidity is being solved or the problem of acidity is sorted out? That is a different issue. Mainly involves some different compounds. So, as I was saying, the main complaint from our elder people comes that they are feeling or they are having acidity after having a meal. Now the solution to that problem, the medical problem, is related with the medicines which are mainly basic in nature. Now obviously we are not going to dive into that much details about which medicines to use, which medicines to not use and the other things. What we are going to do in this class is, we are going to restrict ourselves to only the knowledge about acids and base. We will try to understand how many different types of acids and bases are there. Are all of them same, or all of them are having the same chemical configuration or not? Can we apply the same logic or the same theories to all of them or not? This type of things. So without a further delay, let's just take a deep dive into the topic. So, as I have already written, the acid base theories. Now, in science, what we do is, or what approach we take is, we first develop a theory. Then we try to explain that theory by the help of some different experiments. So similarly, in the case of acid base also, first we have developed some theories. Now, when I say theories, now obviously you guys can understand that there is not only one theory but more than one. So let's name them one by one. So the first one is Arrhenius theory. Second one, Bronsted-Lowry theory. And the third one, and by the way the most modern one, is Lewis acid theory. Now, although we have mentioned here three main theories, but we will start with Arrhenius theory at first. Reason? Well, you guys need to understand why the Arrhenius theory was developed at the first place and its shortcomings. Because if you do not appreciate the shortcomings of one theory, then you will not be able to appreciate the advantages of the other. So from that point of view, we will first start with the Arrhenius theory. Okay, so as the name suggests, our great scientist here is obviously Mr. Arrhenius. Don't ask me the full name or even in comments because I don't remember them, or honestly speaking. What I do remember is that this Mr. Arrhenius suggested that any compound who gives off proton means H plus, they are acids, and any compound which acts as a source of OH minus is a base. So by that definition, our commonly known acid HCl is an Arrhenius acid. Now obviously we do not have only HCl, we have the name of this acid. I need you guys to write down in the comments. And followed by this one. For an additional one or additional stress, if you guys think so, but I see it as fun. So whether you see it as stress or fun, that is up to you. But nonetheless, from the point of knowledge, you should also try to name this cute little guy.
Ethanol.
What is its name? Okay, so these are all what? Acids.
Oh, acid.
Now let's think about this guy. What is the name of that? Sodium hydroxide. And what will be the name of this one here? Well, you see that one has what? Na, oxygen and hydrogen. In sodium, oxygen and hydrogen. Now the OH part is common here and here. So obviously, if that was having the hydroxide part in its name, so obviously that logic will apply here also. This will also have hydroxide part in this with this name. Now the difference is here we have sodium, here we have potassium. So the name will rearrange itself from sodium hydroxide to potassium hydroxide. Similarly, magnesium hydroxide or calcium hydroxide. Well, now all of these are what? All of these are the sources of OH minus ions. Means all of them are acting as bases. To be specific, they are acting as arrhenius bases. And any compound which is producing H plus is therefore acting as an arrhenius acid. Now, if we consider a reaction, say HCl and NaOH, we will then get NaCl plus H2O as products. So HCl is the arrhenius acid in this case, NaOH being the arrhenius base. When acid and base react, we get a neutralization reaction. The product of that reaction is actually salt and water. Now I have a question here for you. Do you think that each and every compound will be having H plus and each and every compound will have OH minus ions? Well, if we try to understand or even think about it a little bit, the answer becomes very much obvious and the answer is no. Not each and every compound will have H plus, not OH minus. So that means if a compound is not having H plus ion or say OH minus ion, so then the arrhenius definition of acid and base is essentially useless in that cases. So means if we have some compound which lacks H plus or OH minus ions, we cannot apply the acid base concept in those cases. So now as a scientist or as a potential scientist, what we do is we try to simplify things. We try to extrapolate our existing concepts to the different compounds. Now this specific concept of acid base, well, let me tell you one thing, that this specific concept of acid base is very much useful for our day-to-day lives also and in scientific researches also. So it makes sense for us to extrapolate this concept of acid and base to other compounds who are not having H plus or OH minus ions. But as you already saw, if we stick to the arrhenius theory, then this becomes a problem for us. So what to do? Well, if you are facing some problem, then it's in the human psyche to develop a solution also. And as scientists are also humans, so they also develop a solution. The solution being another theory known as Bronsted-Lowry theory. The difference between arrhenius theory and Bronsted-Lowry theory is not much, just two letters and a mathematical sign. The two letters are O and H, and the mathematical sign is minus, meaning from in the chemical language we may say the hydroxyl ion. Now what does this mean? Essentially it means that Bronsted-Lowry theory deviates from the arrhenius theory in the sense that when Arrhenius said that only those compounds who are capable of producing OH minus should be considered as bases, Bronsted-Lowry theory didn't mention about OH minus. They said, so what if a compound doesn't have OH minus? So let's see the function of OH minus. What was OH minus doing in the reaction? So if we were having an H plus, OH minus was just accepting that H plus to produce water. So if suppose we have a compound which cannot produce OH minus but can produce something which can be working as an acceptor of H plus. So let me repeat myself here. As per the Arrhenius, or if we take a deeper look in Arrhenius theory, we see that the function of OH minus was to merely accept an proton or a H plus ion to produce water. Now, if it is something to do with accepting H plus, then it's not like that only the OH minus ion has a God-given power to accept H plus ions and no one else has. It's not like that. Aside from OH minus ion, many other ions, or for that matter neutral molecules, also have the capability to accept H plus ions. So Bronsted and Lowry picked up on that point there, and they redefined the acid-base theory as acids obviously being the one or being the compounds who can produce H plus ions. Bases, on the other hand, the definition of bases were changed to define as acceptors of H plus ions. Example, well, for acids, I don't think you guys need another example because we already spoke about plenty of acids in the Arrhenius theory, and as the definition of acid is still the same as it was in the Arrhenius case, so the examples will also be same. But let's look at some bases case. Let's take our one familiar compound. Now, what is the name of this? Not Q, but surely little one here. NH3. It is known as ammonia. Now, what happens if I suppose react H plus with NH3? What will be the product? Well, the product will be something known as ammonium ion. Now, in this case also NH3 is doing what? NH3 is accepting the H plus to produce not water but something else. But still NH3 is playing the role of a proton acceptor very much efficiently. So that means ammonia is an example of a Bronsted-Lowry base. OH minus is also a Bronsted-Lowry base because OH minus does what? It also accepts proton to produce water. So both are actually Bronsted-Lowry bases, but the advantage here is, as per Bronsted-Lowry theory, the concept of acid and base has been, or we were able to apply the concept of Bronsted-Lowry base theory to wide range of compounds. We are now no longer restricted in the H plus or OH minus scenario. We now can apply the concept of acid base to other compounds also who does not have OH minus. That is the advantage of Bronsted and Lowry. But surely, as it has got some advantage, any theory in science is also bound to have some limitations. The limitations and the solutions we will discuss in our next class. So for now, let's have a goodbye.